Okay.
Hello and good evening and welcome everyone to ICU Reach. Tonight is a webinar and that means that it's a more informal setting. Usually we just broadcast a video, whereas tonight you'll be able to interact with Dr. Carola. You'll be able to ask questions, raise your hand, put things into the chat, and during the webinar we'll be able to answer your questions as we go along. It's really to help you understand more fully about our topic. So for those of you who are new and haven't yet joined us, Dr. Mazen Carola is going to be taking the session, and Dr. Carola is an associate professor at the University of North Dakota and the medical director of critical care services at Sanford Health System. Tonight, the topic is on flow waveform assessment on mechanical ventilation. So again, it's an interactive session and we really hope that you get the most out of it. Just to let you know, ICU Reach is an organisation and we have a website. So if you go online and Google ICU Reach, you should be able to find our website. And on the website, there's lots of options. So you can view the different tabs, you can see our research, you can see the blog posts, and you can also register. And by registering, you'll get information about everything that's happening at ICU Reach via your email, so that you can stay up to date. On the website, there's also an area of groups, and there are different groups that you can join, such as critical care and the mechanical ventilation group. And on the group, it acts like Facebook. You can scroll down through the group, you can see the recent posts, and you can like, share, and react to the posts. And it would be great if you can get involved in that. I think it'll be really beneficial. Also on the website, there's an option to donate. As you know, everything that we provide is mainly free. But if you have the financial capability to be able to donate to the organisation to help with the work that we're doing in reaching other people who need the education about ICU, we would be really grateful for your support. So I'm going to pass over to Dr. Carola to start the session tonight on flow waveform assessment on mechanical ventilation. Thank you.
Okay, thank you, Grace. So today we're just going to concentrate on the flow wave. And for those people who did not join us before, everything has been recorded. And you can go to the website and go to previous webinars, and under mechanical ventilation, you will see all the basic and advanced sessions that we had on mechanical ventilation. Again, as Grace mentioned, this is an interactive session, so please interrupt at any time. You can just unmute yourself and talk. And I'm just going to start by describing the flow waveform. And then the way we're going to go through the session is, first, we're going to see the different waveforms in different modes, mainly pressure control, volume control, and then spontaneous modes. We're going to see how we can utilize the flow waves for the trigger. Then we'll see how they are changed with increased resistance, increased elastance, and then dynamic hyperinflation. And I may have to show some slides if we cannot demonstrate the waves very well. And this time I'm going to do it with loops. So, and I'm going to have the first loop is flow pressure, and the second loop is going to be volume and flow. Those loops are going to be kind of small size for you. Do you see that? Okay, Grace, the loops on your side. Okay, so we may have to pay some attention to some details. We'll go through those. Okay, and you're going to have loops on any kind of ventilator that's demonstrating graphics for you. So it's important that you understand how those loops are formed. And usually they are actually plotting two parameters to each other. I'm plotting here the flow on the y-axis and the volume on the x-axis. On the left side, we're plotting the flow on the x-axis, and on the y-axis, it's a pressure. So let's just freeze this and try to identify the different phases of this flow waveform here. What we see first, this is the start of inspiration, and you can see a rise in the flow from 0 all the way up to 30 liters. And in fact, I'm telling the ventilator to go up to 30 liters, and you see that here. So that means I'm setting the flow. If I set the flow on the ventilator, it means that we are controlling the volume. If I set how fast the air is going to go in and what is the time, that means we will have a specific tidal volume. If I set here for tidal volume of 500, that 500 ml at a rate of 30 liters is going to be delivered in 1 second. So 30 liters per minute. If we have a breath for 1 minute, we're going to have 30 liters. All what we need is just half liter. It will take 1 second. So the flow goes up to the maximum set flow, which is 30 liters per minute, and stays at this level. So that's what we call flow limitation or flow control. We're controlling or limiting the flow to 30 liters per minute. Okay, so it stays at 30 liters per minute. Next question, when does the flow go down to 0? Once the job is done. And how much do we need to deliver? 500. So that means 1 second, and then the flow goes down to 0. Did inspiration end? No, it did not. We're setting it up at 1.5 seconds here. So what does the machine do? Well, we finished the inspiratory flow in 1 second. And since the inspiration is not ended yet, so that means we have 0.5 seconds to rest. And that's what we call plateau. So this is the plateau phase of inspiration. There's no air, so it's static. Where's the air? It's inside the lungs. In order to keep the air inside the lung, I need pressure. That pressure is needed to overcome the lung elastance and the chest wall elastance. So you go up here, and you will see, we're not going to be talking much about the pressure, but I just want to elicit this for you. You can see here that the pressure needed to keep that air in is the plateau pressure here. However, before that, with the flow in, I need to overcome the airway resistance. So that's why the pressure goes up to the peak inspiratory pressure here before it goes down to the plateau pressure. So we delivered the tidal volume. We rested for 0.5 seconds here, and then starts of expiration. Now, inspiration is active, expiration is passive. The machine does not do anything in expiration. All what it does is just open the circuit for the patient, and the patient will exhale. The lower the compliance that we have in the lungs, the faster that we can expel that air outside the lungs. So what happens is the flow will go the negative direction, the opposite direction, it's expiratory flow, and it will go all the way to the peak expiratory flow. And then starts going down gradually before reaching before the next breath. It reaches the zero line before next breath. And you need to make sure that the lung empties completely. So you can see here, there's no more flow. So that means we're done. Everything that was inhaled was already exhaled here. So we're done with exhalation. The other thing is, you need to know that the area under the curve, so that is the black area here, represents the tidal volume. So you can see where the tidal volume here is everything under the curve. This is the tidal volume. Of course, you can see the tidal volume also in the curve here. So this is the tidal volume, but from the flow, it is the area under the curve. Let's go back to the loops. And then you need to also see that the area under the curve in inspiration should equal the area under the curve in expiration. So it's hard to do that visually because of the different configuration of the flow. This is square wave compared to see this as like decelerating flow wave in expiration. But when we have leak, you will see that, well, this is very small here. It would be very obvious to you that what's been exhaled is much less than what's inhaled. So in any leak in the system, if we put 500 in, they will be shown in inspiration here. However, when the patient exhales, if we lost 200, all what would be exhaled is only 300, and we'll talk about that. So this is how it's going to be, how the flow waveform will look like in any volume control mode of ventilation. The shape of the flow here is a square. When you see a square, this means that it is volume control, because you're controlling the flow. If you're controlling the flow, that means you're controlling the volume also. You can, in some ventilators, not on Dragar though, in some ventilators, you can actually decide how you want the flow to look like. In volume control, you can do decelerating flow waveform also. So it's not necessarily if it is decelerating that it is pressure control. It could be also volume control. But in pressure control mode of ventilation, you cannot control the flow. And we'll see that once I change to pressure control. In volume control, you can control it. And you can see the control button here, 30 liters per minute. And you can play with that. You can increase, you can increase the flow. I'm going to go up to 60 liters. And this way, I'm doubling the flow. If I double the flow, I still need to deliver 500 only. So the 500 with a flow of 60 liters per minute, it will be delivered in half second. And since inspiratory time is not changed, it's 1.5 seconds, you will see now the plateau time is extended from 0.5 second to 1 second. And you can see that the plateau pressure is used during this time to overcome the lung elastance. Okay. So let's go back to the flow of 60 or 30 and take a look on the loops. So first, I'm going to start with the loop on the right side here. And since I'm plotting the flow on the y-axis and the volume on the x-axis, what I'm going to do here, I'm going to have volume here. Okay. So now what I'm doing here, I'm combining this graph with this graph. And let's start from this point here. At this point, I have a flow of 0 and volume of 0. And you can see here, this point corresponds to this point here, volume of 0 and flow of 0. Excellent. So let's follow it. What happens next? You can see that the flow goes up all the way to 30 liters per minute. And this corresponds to this increase here, goes up from 0 to 30 liters per minute. And that's what I see here. This will correspond to a very minimal volume that is delivered into the lungs. You can see that the volume moved a little bit. You can see this point here, take a column. We have some volume, but it's very minimal. So we have a rise in the flow. With this rise, we're going to have minimal volume delivered. Then what happens with the flow? It stays at 30 liters. And that's why you see that here, stays at 30 liters. Okay, for the duration of the inspiratory flow time. Perfect. And then with this flow at 30 liters, what happens to the volume? It goes up. And that's why we're moving to the right side here. This is the volume. So the volume goes up. We're filling the lungs with the tidal volume. How high would it go to? It's going to go to 500 ml or 0.5 liters. And you can see that here. So the flow stops here. Once we deliver the 500, the flow will go down to 0. And you can see how it goes down to 0. Okay. Now, after that, what happens? You can see that the flow is at 0 and the volume is constant. So how's that going to be represented here? Flow at 0 and constant volume. So it is actually what we need to see here. We need to see a pause. Do you see that pause? If you concentrate a little bit, you can see that flow goes here, comes to this point, stops for 0.5 seconds. Take a look here, stops and then goes on. What I'm going to do, I'm going to increase that flow so you can increase the plateau time. Take a look here, see? Okay, so now I increase the flow, it goes up to 60 liters. I extended the plateau phase. So what you see here, take a look on, see how much? So I go to down to this point here, 0 flow, tidal volume is in. So this is 0 flow, tidal volume is in, 500. Stop here for 1 second. So you have 1 second where we're pausing the system, and you can see that here. Okay. And then goes into expiration. So let's go back now to 30 liters so we can see a bigger flow waveform, low volume waveform. Okay. And continue to follow the loop. Okay. So at this point here, at the end of the pause, we're in this area here. What happens to the flow? It goes down the other direction. Now it's expiratory flow. And it goes fast, it's passive. It goes to the peak expiratory flow. And once we reach the peak expiratory flow here, we started to decelerate gradually. So you can see here, with the peak expiratory flow, we exhaled a little bit. So that's why the flow goes down to the peak expiratory flow, and we lost some volume. So it started moving to the left side. And then it decelerates as the flow goes down gradually. You can see how it's going to go down gradually. We're losing the volume and represent this area here. And that's why the curve goes back all the way to 0. At this point here, the flow is 0 and the volume is 0, and the flow volume loop is completed. Any question here before I move to the flow pressure?
You can raise your hands if you want to ask a question, or you can put it into the chat.
Faisal, is it clear?
Clear for now. Yeah.
Okay. So now let's move to the flow pressure. And again, I'm going to have the same curves that correspond to this loop here. We're looking at the pressure on the y-axis. So I'm going to change this to pressure. And on the x-axis, I'm going to have the flow, and this is where we have the flow at. All right. So let's take a look. Again, we're going to start from initiation of inspiration. At this point here, you start from a pressure point, and that pressure point is the PEEP. And in the system, we have a PEEP of 5. So that's why you're reading pressure of 5 here. So this is a PEEP of 5. Now, if I start from PEEP of 10, you can see how this is now lifted. It is PEEP of 10. You can see we started from this point. If I start from PEEP of 15, now I lift it up. You can see this is PEEP of 15, and now take a look on here. It's very clear to you that we're starting from PEEP of 15. So this is the starting point. We're going to go back down to 5 centimeters of water. So start from this point, which is 5 centimeters of water. Now, what happens with the flow? As the flow goes up to 30 liters and stays at 30 liters, take a look on here. This is the flow. So it goes up to 30 liters per minute. What happens next? It stays at 30 liters. That's why we have a vertical line here. Okay, and that vertical line is the 30 liters. This is the time here. Now, what happens with the pressure? As the flow is increasing, the pressure goes up. And you can see now we're looking at the y-axis. The flow is increasing, and you can see the pressure goes up. So it goes up gradually and continues going up till you reach the peak inspiratory pressure. So this point is the peak inspiratory pressure. Okay. So now this point is represented by the end of the inspiratory flow. And this is the inspiratory flow that goes up to 30 at the end of it, which means this point. When you take a column down here, that would be the peak inspiratory pressure. Okay, what happens next? We have a plateau time of 0.5 seconds. And with the plateau, we have no flow. So the flow you can see here, it goes down all the way to 0. So we're at this point here. The flow is 0. What happened to the pressure? The pressure needs to keep the air in, which is the plateau pressure. So the pressure does not go all the way down to 0. It goes to the plateau pressure. So that's why the pressure, it goes down, we lose the pressure. We don't need any more pressure to overcome the airway resistance. So the pressure goes down and goes down to this point here. What happens next? You pause. And again, let me show you by increasing the pause. Let's just go up on the flow so you can see it clearly. I'm going to double the flow again. And by doubling the flow, I'm going to get that flow in just half second. So you have more time for plateau, you can see it. So it's going to stop here for 1 second. And you can see it. Take a look on this area here. It goes down to this pressure, stops for 1 second, and then expiration. Okay. So let's go back and do flow of 30 liters. And continue. Now we pause for 1 second, for half second. Did it go down? Yes. So we pause for half second. And then what happens next? The flow goes down to the peak expiratory flow. And it does this very passively. So it's going to be taking very little time. So you can see the flow now goes the other direction. This is the 0 line. It goes down the other direction. It goes to minus almost 30. Is that correct? Yeah, minus 28, 30 liters. And starts to decelerate. So as it decelerates, of course, we lost the pressure. We went down to right away to PEEP of 5. So that's why we went down from the flow goes down to minus 30, and the pressure goes down to the PEEP, which is 5 centimeters of water. And then it decelerates gradually to go back to the 0 line. So you can see how it's decelerating here, and it's going back to the 0 line. Now train your eyes to look at these two loops together. You can see here how nicely they are depicted. This is the flow over volume. Flow goes up to 30 liters, stays at 30 liters before it goes down. This is the plateau phase, stops for 0.5 seconds, and then exhalation, peak expiratory flow, deceleration goes down to 0 before the next breath. In the pressure over flow loop, the pressure starts from 5 centimeters of water. The flow goes up to 30 liters. As it goes up, pressure goes up gradually. Flow goes it stays at 30 liters. The pressure continues to go to the peak inspiratory pressure, I'm sorry. And then it goes down to the plateau pressure. The flow goes down to 0 because it's a plateau, and then starts going to expiration. The pressure goes down to 5 centimeters of water, which is the PEEP. The flow goes down to the peak expiratory flow before it decelerates and go back to the PEEP level. This way we complete the loops for volume control mode of ventilation. Any question? Chris, do you have any question yourself?
No, I actually think you've explained it really well so far, so I don't have any at the minute.
Excellent. So let me ask Faisal.
If anyone has any questions, just add them to the chat, or you can put your hand up. Either way, it's very helpful.
So Faisal, let me ask you a question if you don't mind. Can you unmute yourself? Is he with us?
Yeah, I see. Yeah.
Sufyan?
Yes, sir.
Okay. Can you define plateau phase for me? Based on the graphics. The plateau phase, just give me graphics and mechanics, dynamics. If you have a definition for the plateau phase that includes everything in terms of the dynamics, mechanics of the air in the plateau phase, what would that definition be? It can help you out also. How would you define a plateau phase?
It will be like no flow.
Excellent. So it is a phase that has 0 flow. So if you want to identify the plateau, you have to make sure that the flow is 0. So let me help you out. Is this going to be inspiration or expiration? Yes.
Inspiration.
Inspiration. So it has to be, you look for the plateau in inspiration where yes, it's after the inspiratory flow where the flow is now becoming 0, but inspiration is not ended. You wanted to say something about the pressure, right?
Yes, maybe pressure constant.
Okay, and the pressure is constant at the level that is needed to overcome what? Why do we need to keep pressure in the system?
To keep the alveoli open.
So what do we overcome? Airway resistance or lung elastance and chest wall elastance?
Elastance.
Excellent. So if you want to give a definition for the plateau phase, you would say it is the phase of the inspiration where inspiratory flow is ended and the flow becomes 0. So it is a static wave, a static phase, and the air is already in the lung. In order to keep that air in the lung, we need to utilize the pressure. That pressure is the plateau pressure, and it is constant pressure that is needed to overcome the lung and chest wall elastance. In other words, the higher the elastance, the higher the pressure that we require to use in order to keep that air in the lungs. Thank you very much. So with this, let me go to pressure control mode of ventilation and see how things are changed with pressure control. So, and again, we're concentrating on the flow here. And you can see that with what we see here that the shape of the flow wave is changed. It was a square wave. Now it is decelerating wave, meaning that the flow goes up to maximum inspiratory flow before it decelerates. And this decelerates in inspiration, meaning that there's still flow, but the flow is decreasing. We're filling in the lung gradually. Now, can we control that flow? Let's take a look. You will see here we lost the flow. There is no flow control here. The flow is not controlled by you, by the operator anymore. You're controlling the pressure, but you're not controlling the flow. So if you go up on the pressure higher, you can see that we just go up on the flow. You can see here we have a higher flow. Let me freeze this. So since we used higher pressure, you can see how the flow was adjusted automatically with a higher flow. And of course, it's going to deliver higher tidal volume. Let me go down to 15 centimeters of water and take a look on it. So I'm down actually. You can see here how this is 25 and this is 15. And you can see how the flow is decreased. Okay. So there's no more control for the flow. It is done by the machine. You're controlling the pressure, and the higher the pressure that you utilize, the higher the flow. And the flow waveform is always decelerating. So you cannot have a square wave in pressure control. In other words, if you see a square wave for the flow, this is for sure, it's a volume control. But as I mentioned, the decelerating wave, you can still do volume control with decelerating wave, but you cannot do pressure control with a square wave. So this is first thing. You can see that the area under the curve now is actually close to that you can visually be able to compare inspiration and expiration. As I said, the area under the curve is the volume. So this is how much volume was put in the lungs. And this is how much we exhaled. Area under the curve in exhalation is the volume that is exhaled. Okay. So again, this is the start of the inspiration. The flow goes up to maximum flow and you don't have any control on that. You're controlling the pressure. You can see with this, the pressure goes up from 5, which is the PEEP, all the way to 15 centimeters and stays at 15 centimeters because it's controlled. That's where you're setting it up. And since inspiration is 1.5 seconds, you can see the duration of this is going to be 1.5 seconds. And what happens to the flow? It starts decelerating during this phase till the end of inspiration, which is 1.5 seconds. And then the flow goes to passive expiratory flow. So this is active and this is passive. And this is going to be very similar to the previous one. So it goes to the peak expiratory flow and then decelerates all the way down to 0. Now, let's see how it's going to be depicted on the flow over volume. So it's going to be very, very similar, except you're not going to see the constant flow. You can see here, the flow goes up from 0, which is this point. Again, let me just put the volume for you. Okay, so it's going to be very similar. It goes from this point to the maximum inspiratory flow, which is this point. Before it decelerates, you can see how it's going down and gets to this point here. Once we get to this point, the inspiration is ended and there's no plateau here. You can see how it's continuous. So it does not stop. So we reach this point. This is tidal volume that was delivered. And this is determined by 1.5 seconds. So from here, to this point is 1.5 seconds. Once we reach the 1.5 seconds, this is cycling. At that time, we're going to go into expiration. That's why the flow goes down from this point here all the way to this point. So that means it goes from this point here down to the peak expiratory flow. And of course, this is going to be very similar, starts to decelerate gradually to go back to the zero line. So this is end of inspiration. I'm sorry, end of expiration. On the flow over, on the pressure over flow loop, it's, again, let's just have the pressure here and monitor. We start from peak of 5. This is the point of peak of 5. And then we're going to go up on the pressure from this point to this point. You can see how fast it went up from this point to this point. This is the pressure. At the same time, the flow went up from this point to this point, and this is how fast it went up from this point to this point here. So this point corresponds to this point here. And then take a look, pressure is constant. That's why, look at this, pressure is constant now. It does not go down. This is the phase of inspiration that we're controlling that pressure. So the pressure stays at 15 centimeters above the peak. Once we reach this point here, this is 1.5 seconds. So that means we ended inspiration. So this is the end of inspiration here. What did we do? We went down the pressure from 15 centimeters to 5. So that's why you see it here, 15 centimeters to 5. And all the way down here, this is a 5. So it goes through the zero line here. This is for the pressure, and it goes to 5 centimeters, which is the peak. Now with this, you can see that the flow goes from this point here all the way to the peak expiratory flow. So this point here is around 10 liters per minute, and you can see, so this is the plateau, or I mean the controlled pressure. This is inspiration, this is end of inspiration. Take a look on the flow, what happens to it? This point is around 10 to 12 liters. So if we take a column here, it's about this, and this corresponds to this point here. Now we go from this point all the way to the peak expiratory flow. So we go down from this point here all the way to peak expiratory flow. You can see here is minus 30 or minus 35, around that range actually, in the middle between 25 and 50. And this point corresponds to this point here. Okay? And then starts decelerating gradually to go back to the peak of 5. And this would be corresponding to this point here. Zero flow, you can see zero flow and peak of 5. So this way, you would be able to understand the waveforms in pressure control versus volume control mode of ventilation. Any question? Okay. So now what we're going to do is we're going to let the patient breathe, and I'm going to use spontaneous mode of ventilation. Okay, and see what happens. Okay. So with spontaneous mode of ventilation, you notice that we have a sine waveform here. It's not anymore squared, it's not anymore decelerating. And in fact, the color of it's changed, and this is gray color. On the radar, it indicates that it is spontaneous. Okay. And with this, there's no positive pressure. Why? Because it was spontaneous. The patient is doing the efforts, and the pressure is decreased because of the inspiratory efforts of the patient. So the patient decreased the pressure inside the circuit. He generated a pressure gradient, and that led to an inspiratory flow. That inspirative flow goes up gradually to higher level, but you can see how it is sine wave. It doesn't go to a plateau or anything like that, and then decelerates. So take a look on here. We're going to go look at the volume and the flow in spontaneous mode of ventilation. So let's just go to volume here. Okay, so what you see here is the flow goes up gradually and reaches it's not a plateau, but it's like, stops at certain point and then goes down gradually. So it is sine wave. With this, the volume is going up gradually. You can see the volume goes up. This is a tidal volume that was delivered. There is no plateau here. You can see that the flow goes down to 0, which is this point here, before it goes down to the peak expiratory flow and decelerates to the 0 line again. That corresponds to this area here with the ventilation going down. I mean, the volume being exhaled and going down to 0. On the pressure flow loop, okay, it's hard to see here. Why? Let's just get the pressure, because we only have a very minimal pressure. So the pressure goes down to minus. That means it goes down from 5 to 4. And with this, we're going to have inspiratory flow, okay, and then expiratory flow. So that's why you can see the line going this way and then going backward, this way and going this way. So because the flow goes up to 30 liters, and then goes down to minus 30 liters, goes down to minus 30 liters. What happens to the pressure? It's only negative in inspiration, and then it goes down up to the peak level. So very simple. I can put pressure support here, see how that's going to change. So let's put pressure support of 10. And notice what happens when I put pressure support of 10, the flow wave becomes decelerating. So this is similar to pressure. Remember, I said in pressure control, pressure regulated, pressure supported breath. I said that in the previous sessions. It's going to be decelerating waveform for the flow. And that's what you see here, okay? Decelerating flow waveform. Somehow it's not actually, let me just see. Let's go up to 12. Okay. It shouldn't be this way, actually. Let me do it again. And this is simulation issue. Okay. So let me share my screen again. And let me start again and put the patient on pressure support mode of ventilation. So the CPAP, and this is my pressure support of 10. Okay, that looks better. And now let's take a look here on loops. We're going to get volume flow and on pressure flow here and volume flow here. Okay, so what you see here is exactly similar to the pressure control waves that we saw already. You can see that the pressure goes up to the the flow goes up to the peak inspiratory flow. Peak inspiratory flow. Let me just freeze this one. It's peak inspiratory flow, and then decelerates before it goes up to the peak expiratory flow. For the pressure flow waveform, we start from peak of 5. So we start it was reversed here, actually, so you can get yourself familiar with different waveforms. Now the pressure is on the x-axis and the flow is on the y-axis. So you can see how the pressure goes up from 5 to 15, and this would represent this area here. And then it stays at 15, so that's why it doesn't change. What happens to the flow? It goes up this is the flow. I just unfreeze so you can see it again. All right. So this is the pressure stays there, but the flow continues to go up. And then the flow decelerates, and you can see the deceleration in the flow here. Okay. And that is this area here. It goes down after that from this area all the way to 0. Okay. And since this is flow with sorry, we put the wrong one actually. Let me just repeat this for you. This is flow and pressure. Okay. Let's take trace it again. So this is flow and pressure. So this is the pressure, and this is the flow here. So you can see that the flow goes up from 0 to probably 40, and it goes up to 40 here. Okay. What happens to the pressure? It goes up from 5 to 15. So where is the pressure here? It's on the y-axis. Goes up from 5 to 15. So this is the point. And then it did not trigger here. And then the flow starts to decelerate. The pressure is constant. So you can see the constant pressure here. This is constant pressure. And the flow starts to decelerate. You can see that the flow goes from this point to this point. At this point here, the pressure is released, and you can see the pressure is released all the way, and the flow becomes negative. It goes to minus 30 or minus 40 liters, minus 40 liters, and then starts to decelerate gradually. So when it's not triggered, actually, you don't see much. It decelerates and goes back to the peak level. Okay. Any question? So we've seen the loops on different modes: spontaneous modes, pressure support mode, volume control mode, and pressure control mode. Any question? Okay. So
Hey, Dr. Sharala, thank you so much for this detailed lecture. And my question is unrelated to the slides that you did. It's actually wanted to know what kind of app you use. Is that something provided by Drager, or is that something you purchased or something? Because I was kind of discussing with my program director, previous program director, that there's the existence of this app, which helps a lot the educational quality of the fellows in the future. So I just needed a little more insight if that's possible. Thank you.
And this is Hussam Naif, right?
Yes, correct.
Okay, and remind me, where do you work at? Which hospital?
It's called the Ascension St. John Hospital in Detroit, Michigan, and I graduated. So now I'm responsible for my awards.
Yeah. So certainly. So now St. John is called Essential St. John.
Yeah, they unfortunately that happened.
Yeah, so they merged with Essentia, or they bought by Essentia. They were bought by Essentia.
They were bought.
Right?
They were bought. Yeah, they were bought by Essentia.
I didn't know that Essentia actually goes all the way to Michigan. Anyhow.
Yeah, yeah, it does. Yeah, yeah. I mean, Wisconsin, you know, Chicago and Michigan. Yeah.
So the software is a free software that you can have and download on your computer. It's it's an execution program. So, it cannot be it cannot be sent by emails. The emails will not. It's EXE program. So it doesn't because it will be read as harmful to your computer, so it won't be sent by email.
Okay. Okay.
You have a way to communicate with me?
You know, I think I have your email. So I may just send you an email.
Send me an email. I can send you a link.
Okay.
And you can
Yeah, I do.
download.
It's an iCloud email. Is that the one you use?
You can put mkerallah and you can put any extension because I reserved
Okay.
all the emails
Okay.
under my name.
Okay, yeah.
You
I
can do
have your email.
MSN or iCloud is fine.
Okay. I'll use the
mkerallah.
iCloud. Yeah.
Yeah,
Sorry to
so and
interrupt
I can
your
send you. That's fine.
beautiful
I can send whoever wants. Not only you, Hussam. Whoever wants the software, you can send me a request, and I will send the link to you. It is already uploaded to the website, but you don't have access to it from the website. But there are some glitches in the software, so it's not complete. So you need to understand that, and this is actually probably 10 years old software. There's another software for the newer ventilator, but I didn't like it. I think I like this one better. It's very, very well organized, and you have a patient with it too.
Awesome.
No problem. I just want to go quickly, if no one else has any comments or question. And because it took actually more time, I wanted to explain, we never had discussions about the loops. That's why I wanted to give enough time for the loops, so you can understand them very well and be able to build up on your previous knowledge that we all learned together throughout those sessions. Again, those sessions are actually every 2 weeks. I pick up a random topic, but if you want specific topic, you can send me a request. At the end of this session, you're going to have only 2 questions. First one, whether this was helpful to you, informative, you can be honest. You have a scale from 0 to 10. If you put 0, I will never accept you again to attend this. You can choose whatever number you want. And the second field would be just give me, if you have any suggestion for future topic, just put it in. And you probably notice people who gave me suggestions, where those suggestions were actually presented in topics. And next session is going to be about nutrition, which was one of the suggestions that we had from previous webinars with the feedback. So let's just see how things are changed with this is let me put volume control again. I want to use the same thing. You probably notice that I use the same numbers, so for you not to be confused. The purpose of this is to learn, and then you will be able to build on it. If you understand the basics of mechanical ventilation, you'll be able to build on. If you understand them the way I understand them, I think it's going to be easy for you to understand any mode and be able to build up and be able to interpret any abnormality that you see. So we're going to increase resistance and see what happens. So with this, I'm going to freeze it here. So how is that going to be reflected? You will see a couple of things. First, let's take a look on the flow volume loop. The flow is going to be the same thing. No change in the flow and volume in inspiration. You can see that. It's exactly the same. However, notice in expiration. In expiration, look at the flow, the previous one. It is the peak expiratory flow is diminished. So you can see how it's moving from this point up here. It's diminished. It is slower, taking longer time. And it may actually not end up at 0 line. Let's just repeat this and see if we can actually see a nicer one. I didn't like it actually. So let's see first without increased resistance. Okay, so take a look on this to see how nice it is. This is expiratory flow and going down to 0. Now, I'm not going to freeze it. So let me just go up to, okay, take a look now. Look at this. Peak expiratory flow is decreased. And look at the time is taken much longer now with the flow. And it did not go all the way down to 0. Take a look on this. See where we ended at this point here. It did not go down to 0. Let's go up higher and let's just increase the rate so you can see it in a better way. And this way, I'm talking about dynamic hyperinflation syndrome too. So take a look on here, take a look on the flow. Inspiratory flow is the same, it's not going to change. And this is volume control, you're controlling that. But expiratory flow, look at this. Peak expiratory flow is diminished, the slope is diminished, and it's very slow. It's taking longer time. And it does not go all the way down to 0. So it doesn't reach this point here. You can see how it ends here. Take a look on here. See that? It ended before the volume was completely out. Let's make it worse so you can see it. Okay, see that, how it ended here? See that? Very nice. Okay, so this is the trapped volume. Of course, with time it's moving to the left. This is software glitch. Okay, but this is the trapped volume here. So on the pressure flow, this is the flow and this is the pressure. All what we see is higher airway pressure, higher peak inspiratory pressure. And that's, you can see how it is actually shifted to the left. It's a higher pressure now. The inspiratory flow is the same, but it's higher pressure. Inspiratory flow is the same, but higher pressure. With expiration, so the flow goes down here to the peak expiratory. You can see the peak expiratory flow is diminished. And look at this, how it's actually going down from this point here to this point here, and it does not go down to the 0 flow. It stops here, and that means that this is the point of end of expiration. And the next breath starts from this point here. It starts from negative flow, and you can see that here. This is a negative flow and starts from here and then goes into the next breath. Any question? So now let's see that. Go back to normal resistance. Okay. And I just want you to see we're out of time actually. It's only 5 more minutes. We started late. So let's go down on the rate. And go down on the, keep the loops. We need them. And go down on the compliance. Okay. So with the decreased compliance, what do we see different? Okay. So the flow, inspiratory flow is the same, no changes. Expiratory flow, you can see how we went deeper. So it's larger expiratory flow. The peak expiratory flow is increased. And it's taking shorter time to exhale. You can see it's faster. And we go down to the 0 line here before the next breath. So if you don't have the loop of the previous one, it would be very difficult to determine the differences. And this is on the volume flow. On the pressure flow, what happens is that the peak inspiratory, the airway pressure is the same, the peak inspiratory pressure is increased. So this is what's increased, the peak inspiratory pressure, this pressure. And then you have a plateau. Okay, you can see the pressure goes down to this point here, and the plateau is increased. You can see this, the plateau here is increased. I did not show that actually in the previous one. The plateau is the same. It did not actually go up. It's only the peak inspiratory pressure. You can see the difference between this line here and this line to determine the difference between the peak pressure and the plateau pressure. So the peak pressure is actually this line here. I mean, this point is the peak pressure. And this point is the plateau pressure. and this point is the P pressure, yes. I may have misspoke actually earlier. Peak pressure, plateau pressure, peak pressure, plateau pressure, peak pressure. So in decreased compliance, you're going to see that the plateau pressure is increased. And the difference between the plateau and the peak is the same. If I change to resistance problem, let me go up on the resistance and we'll make this normal. So you can see the difference. Okay, take a look on here. Peak pressure here, plateau here. So the difference between this point and this point is not changed. This would be this difference between this point and this point. But the change is the peak pressure and the plateau pressure here. And see, this is the peak pressure and this is the plateau pressure. Okay. Any question? Okay. If not, I'm going to stop sharing and look forward for your participation in the next session. Any question before we end?
There's no questions in the chat at the minute.
Okay, excellent. So thank you very much, everyone. See you next time. So Grace, we need to end this and then come back again on different one. I'll send you the link. All right.
Thank you.
Excellent. Take care.